Welcome to the online lectures for software engineering. In today's class, we'll be beginning with the topic software quality assurance. Now, what is software quality assurance? So, software quality assurance, it encompasses of 6 things. The first one is the software quality assurance process. That is what process you follow within the software quality assurance. The second one is the software quality assurance. SQA is short form for software quality assurance, and it is a quality control and the quality control tasks. Now, what are going to be the quality control tasks? The quality control tasks are going to be some technical reviews. That is, if you conduct some specific reviews about the technology that you're being developing, like an interview session, then you get to know where your project stands. And you're also going to have certain testing strategies, a multi-tier testing strategies are going to be there. Then you're going to have effective software engineering practices. You're going to follow some specific methods and tools. Then the fourth one is you're going to control all the work that is done, and if any changes are made within the software, you're also going to follow those. Then you're also going to follow a procedure, and this procedure is going to see whether you're following what needs to be developed. You're going to ensure so that you can ensure that the software that you're developing, that you want to develop, is the one that you're developing. Then you have a measurement and reporting mechanism. Now, measurement is going to be the work that you've been doing, and reporting mechanism, if you're falling short of your deadlines, something like that, these things are going to be within the reporting mechanism. When you might not be able to reach the deadline in time, or there are some issues within the technology, or some specific bugs, errors are there that are not being resolved, or some requirements problem is there, that is they are not implemented the way the user wants them to implement. So these are the things that your software quality assurance is going to encompass. So these are 6 things that software quality assurance is going to have. Now there are a few terms that we need to know. Now, starting with the term quality. Now, here quality is defined as a characteristic of or attribute of something. Now, what is actually an attribute? An attribute, it can be said as a measurable characteristic. Now, if suppose there is a person, for that specific person, the attribute can be his age. Now, this age, it is a measurable characteristic. It is a number. He can have his weight, that is again a number. His identification number, that can be again a number. House number, it has a combination of characters and numbers. So these are your attributes. These are your measurable characteristics. Now there are 2 types of quality: quality of design and quality of conformance. The first one is quality of design. Now, this quality of design, it refers to the characteristic that designers specify on a specific item. Now, let's take a few examples of quality of design. This can be the grade of material that you're using, what quality it is. It can be the performance, the specifications, or tolerance also on a specific application. So these are your qualities of design. Then the next one is the quality of conformance. Now this quality of conformance, it is the degree to which the design specifications are followed during manufacturing. That is, what are the specifications that you're following while you're producing that particular software. And let's take a few examples in this. Or we can say that within the quality of conformance, the greater the degree of conformance is there, the higher is going to be the level or the quality of conformance. That is, if you have the degree of conformance is high, that means that the quality of that particular product and the quality of conformance is also high. If greater is the degree of conformance, then higher is going to be your quality of conformance. Then the next term is software quality. Now this software quality, it is defined as conformance to explicitly stated functions. That is, you want some specific functions, some specific features you want within the software. So these becomes your explicitly stated functions and performance requirements. That is, you want this particular software to be some percentage of accuracy you want. That is your performance requirement. And explicitly stated document development standards, that is, you're developing a particular software, you want that particular software to have the best quality standards, so you need to follow that specific standard. This can be an ISO certified standard that you need to follow while developing the standard, and implicit characteristics that are expected of all professional development. Now these are stated, and some characteristics that the end user is not going to state, but he wants that particular software, some specific characteristics that need to be present within the software, that like the user interface, it should be simple, the performance should be very high. These are the things that are expected while you're developing the software. Now, in software development, the quality of design, that is, whenever you're designing the software, the quality of design, it encompasses a few things. That is, requirements. When you want the quality design to be very well, you want it to be the best, then you are going to focus upon the requirement that needs to be there within the software. Then some specific specifications that you need to follow, and the design of the system, whereas the quality of conformance is an issue focused primarily on implementation. So this particular quality of conformance, as you've seen, that as high is the degree of quality of conformance, higher is going to be the conformance. So this is how the quality of conformance becomes an issue for implementation. Now, if the specific implementation, if the implementation follows the design and the resulting system meets all the requirements, then the quality of conformance is going to be high. Now, this issue can be resolved if the implementation is going to follow the design and the requirements that the system needs to meet. So this is going to give you a high quality of conformance. Now, this software quality assurance, it is an umbrella activity that is applied throughout the software process. Now, umbrella activities, within the first unit, we have studied within the first class the different umbrella activities. Now, those umbrella activities, they are applied to any software in an iterative manner, in a sequential manner. Now, this, it encompasses of a quality management process, that is your SQA process, as I've previously mentioned. Then the next is effective software engineering technology, that what technology is specifically used for designing the software. Formal technical reviews, these are used so that you're going to avoid errors, you can follow, you can meet the deadlines. Then multi-tier testing strategy, so that you ensure there are no bugs within the software and the particular software is doing its job. It is doing what it was designed for, that is, it serves the purpose or not. You're going to ensure that it serves the purpose. Then control of software document and the changes made to it. Now, whenever you're developing a software, there are going to be a few changes. These changes can be there by the end user side or from the stakeholder side. So whatever changes you're making within the software, they need to be documented and they need to be taken confirmance from the software product manager, so that you have everything in written that these changes were made by the request of some end user or stakeholder, and these are being approved by the manager. Then the next is a procedure to ensure compliance with software development standards. That is, when you're developing a standard, when you have decided that some specific standards need to be met, so you need to have a process. That is, if you need to achieve a specific goal, you need to have some specific steps that you need to follow. So these steps are your procedures, and your goal becomes your standard. The next is measurement and reporting mechanism. Measurement is, it is going to ensure that these specific standards are met, whether you're meeting the deadlines, and reporting mechanism, if there are any shortcomings within the software, those can be reported to the managers. So this is your software quality assurance. Now, coming on to the background issues. Now, the quality control and assurance are essential activities for any business that is produces product to be used by others. That is, whenever you are into a business of developing software, the main thing is quality control, and that is your software quality assurance is the main thing. You need to ensure that the quality is the best. Now, this quality control, when within the first place, when the software quality assurance was started, this quality control, it was the responsibility of the person that have designed the product, the design, or the person who had built that specific product. He was only responsible for maintaining that particular, he was only responsible for controlling that software. But as time passed, the quality control, it became the responsive it is not only the responsible of the person who have built the software. This has become a responsibility of people other than the designer. Now, first quality assurance and control function, it was introduced at the Bell Labs in 1916, and as it was developed in 1916, then it spread rapidly throughout the entire world. It spread through the entire manufacturing world. The SQA group serves as the customer in-house representative. That is, now what does the customer in-house mean? That this is the people who perform the SQA. They must look at the software from the customer's point of view. Now, in-house means it is like you are not the one only who's designing the software. You are going to look yourself as the one who's going to use the software. That is called as your customer's point of view. That so SQA is going to provide you with this in-house representation. Now, coming on to the elements of SQA. Now, the software quality assurance, it encompasses of a broad range of concerns and activities that focus on the management of software quality. Welcome to the online lectures for software engineering. Today we'll begin with the topic goals, attributes, and metrics. In the previous classes, we've studied what software quality assurance is, and we've also studied the different actions or different tasks for software quality assurance. Now, why are we going to perform those tasks? Those tasks are performed so that a few goals can be achieved. Those goals are requirement quality, design quality, code quality, and quality control effectiveness. Now, what is requirement quality? Now, this within requirement quality, the software quality assurance team, they must ensure that the software team is properly reviewed and it is going to achieve a high quality software. Now, here high quality software means it should give you correct result. It should have correctness. It should be completeness, consistency. These all things should be present for the requirements. That is correctness of the requirements, completeness, and consistency. The next one is the design quality. Now, the design quality here means that whatever design that you're developing, every element within the design model, it should be assessed that it should be the high quality. Whatever you're developing, it should be the highest quality. So the software quality assurance team is going to look for each and every attribute of the design so that they should be achieving the high quality. Every element is assessed for quality. The next one is code quality. Now, code quality here means the source code. Now, the source code of whatever you're writing code for your program, this source code, it should have the coding standard, that it should meet all the coding standards. Should not be very complex. It should be simple. It should have the all the characteristics for maintaining. So you should maintain the quality of code. The next one is the quality control effectiveness. Now, within this quality control effectiveness, a software team is going to check that all the resources in such a way that everything should be the high quality result. Each and every resource is going to be checked that it should achieve a high quality result. So here we have got the table where you have got goal, attributes, and metrics. Now, for each and every goal, that is your requirement quality, what are the different attributes? You've got ambiguity, completeness, understanding, volatility, traceability, model character, clarity. So for each of them, you have a metric. The same as for design quality, code quality, and your QC effectiveness. So there's a table that has got all the attributes and metrics written in place. And then the next one is statistical software quality assurance. Now, statistical quality assurance, it reflects all the different growing trends that are there within the industry. So the statistical quality assurance follows a few steps. The first one is information about software errors and defect is collected and characterized. That is, there are specific errors that that there is more likelihood that they are going to occur. Then you also know, when you know what error is, you will get to know how that error falls in what category and how you're going to resolve it. So software quality assurance is going to do this, categorize all the different types of errors. Then the second one is an attempt is made to trace each error and defect to its underlying cause. Now, once you have made different categories, if there's a category one is there, category two is there. After that, what you can do is that when you know what category it falls in, you're going to identify how you can resolve it, how you can trace it back to the to that specific line of code. Like there is a example, there can be a design error, or the standards are not met, so that as a standard violation is there, or there was poor communication with the customer so that you did not gather all the requirements correctly. Then the next is using the Pareto principle. Now, this Pareto principle states that 80% of the defects can be traced to 20% of all possible causes. That is, isolate the 20% in the vital few. 80% of the defects, these are traced to 20% of possible causes. That is, you do not understand what the customer has said. That is going to be your Pareto principle. Then once the vital few causes have been identified, move to correct the problems that have caused the errors and defects. You've categorized all errors. First step, you've categorized all errors. You've identified what is the cause. You've identified if there's any poor communication using the Pareto principle. Then you're going to correct all these errors. And the next topic is software reliability. Now, what is reliability? Reliability is a measurable system attribute. So non-functional reliability requirements may be applied quantitatively. Now, this is going to define the number of failures that are acceptable during the normal use of the system. That is your reliability. Now, what is functional reliability? Functional reliability means requirement that define system and software functions that avoid, detect, or tolerate faults in the software and so ensure that these faults do not lead to system failure. Now, reliability means there is an error and system can accept that amount of error, that number of error is acceptable. Whereas in functional reliability, it happens that you get to know that there is a specific error, you're going to try to avoid it, and you're going to ensure that this specific error, it is not going to cause some system failure, that is the entire system crash. You're going to avoid the system crash. Error should not cause the system to crash, that is a system failure. So that is software reliability. Now, within software reliability, of the software reliability and availability. In software reliability, the probability of failure-free operation of a computer program in a specified environment for a specified time. Now, what is the within software? Now, here we have seen what is reliability and what is functional reliability. Now, software reliability means that what is the probability that there is going to be no error or no failure within the system when you're executing a specific program at a specific time. That is your software reliability. No error in a specified time. Then the next is availability. Availability is the probability that a system at a point in time will be operational and able to deliver the requested service. Available means the specific operations and features, these are available to the customer. Now, if we take an example of this ATM, if we take an example, sorry, for a bank. Now, the bank is going to function for up to 3 p.m. or to 4 p.m., right? but still you can make transactions using the ATM. That is, the services of the bank are available by the ATM. You can be able to withdraw cash or make online payments by making use of your of the given customer ID. Online banking systems you can use. So that is availability. Those specific features are available at any time, as ATMs are fully functional for 24 hours. So this is software reliability. Now the reliability specification process, it has got a few categories. That are the risk identification. Risk identification means you're going to identify why the system has specifically crashed. Risk analysis, you're going to identify how much it is going to cost you when the system crashes. Risk decomposition means you're going to identify what is the main cause that caused the system to fail in the first place. Then risk reduction means when you know what is the cause that the system is failing, you're going to identify and you're going to try and avoid those type of errors. That is, generate reliability specifications and define acceptability levels of failure. That is, if suppose a specific file is not being executed, how much is your level of acceptance? So that's your reliability specification process.